Okay, so hearing, we're going to do hearing today, and then we'll actually get into equilibrium for the next one. So looking at the structure of the ear, there's three parts, and you'll need to know what each contains. So the external ear, the middle ear, and inner ear. So you've probably heard, oh, so-and-so has an inner ear infection or a middle ear infection. There are different parts. And your ear is very important in hearing and equilibrium. And the lab that we do with equilibrium is kind of fun. You'll get to see some different things with that. So outer ear or external ear consists of the auricle, which is your ear flap. So the auricle is your cartilage, your actual ear, which collects sound waves that are going to travel down that external auditory medius, which is that opening into the skull. So if you, and this is kind of fun, it's kind of weird, but if you hold your ears and you hum to yourself or talk to yourself and then bring your ears forward, it will magnify, you will get louder. And people that have big ears do collect more sound waves. So big ears is not all that bad. So the auricle is what collects the sound waves, and it travels through that opening that goes inside of the skull. The medius ends at the tympanic membrane, which is your eardrum. So the eardrum vibrates with the sound waves. So eardrum is part of your outer ear. I mean, the auricle makes sense because you see that on the outside. Into your eardrum is still considered part of your external ear. So here I can see, here's the auricle, here's the external acoustic medius, that's where the sound travels in and it hits your tympanic membrane. From there, it's going to hit three small bones, the hammer, anvil, and stirrup, or malleus, incus, and stapes. And then it's going to go through, it's called an oval window. It's another place it's going to collect the sound waves. Going to go into your semicircular canals. It's going to go into your cochlea, and we'll talk about those. Vestibulocochlear nerve, that's the nerve that's going to carry the information out of your ear. So this is in your book, this picture's in your book, and as we talk about the different parts of the ear, you can refer back to that. So middle ear, also called tympanic cavity, comes after your eardrum. So it's those three auditory ossicles, is a fancy word for small bones, hearing bones. The three auditory ossicles, malleus, incus, stapes. Or if you've heard, have you heard hammer, anvil, stirrup? And that's kind of from their shape, the way that they look. So the eardrum vibrates. That causes the malleus to move, which is attached to the incus, that moves, and then the stapes moves. When the stapes, the last little bone, moves, the fluid, there's fluid inside the oval window, and that's basically when it's changed from sound waves in air to sound waves in a fluid. Auditory ossicles are going to transmit, and they also amplify the sound waves a little bit. They are bones. Hard material transfers waves better than air. So if I'm talking in the air, or if you knock on your table and listen to it, and then put your ear down on the table and knock on it, it's going to be a lot louder when your head is on the table because sound travels louder through hard objects. So those bones amplify sound waves a little bit. And they are the three smallest bones. So this is just showing you, if I have a penny, here are those three bones. They're extremely tiny. Auditory tube, also called the eustachian tube, connects the middle ear to the nasopharynx, so nose, throat area, to help maintain air pressure. So this deals with like when your ears pop, when you're on a plane or driving through hills, things like that. The eustachian tube's job is to maintain equal pressure. Mucous membranes line the inside, and mucous membrane infections of the throat can actually travel up into your ears and cause middle ear infection, and really kind of work the opposite way too. All of those, basically your ear, your nose, and your eyes kind of all end up coming together. So if I have like a strep throat, some type of throat infection, I can also end up with middle ear infection because it can travel up the auditory tube. Okay, so auditory tube is the end of the middle ear. Inner ear is made up of a lot of labyrinth. So if you read Labyrinth, or there was some movie, what does labyrinth mean?
I have no idea.
It deals with like tunnels kind of, or canals. So labyrinth, there's going to be a lot of canals that are inside of your ear. Osseous labyrinth that's made of bone, and that's in your temporal bone. Between those, the fluid that's located in those is called perilymph. So this would be the fluid that's located inside, or in between the two. Endolymph inside is located actually inside of those tunnels. The cochlea is what looks like a shell. It's shaped kind of like a shell. The cochlea is the part that actually holds everything that hears, where actual hearing takes place. And the semicircular canals that sit further on top are more important in equilibrium. So cochlea, hearing, semicircular canals, equilibrium. Their functions are different. And here they are. So here's the cochlea. This is responsible for hearing. And here's those two, here's these tunnels that I was talking about. The perilymph is going to be located in these outside tunnels. The endolymph is located completely on the inside. So inside of the cochlea, this is hearing. These larger parts are your semicircular canals, and same thing, endolymph is going to be completely on the inside. Perilymph is going to be found in this grayer outer part. Inside of the cochlea, the oval window was the last part that we talked about, leads to something called scalae vestibuli, and we'll look at that. That's going to be a compartment, an upper compartment. The lower compartment, scala tympani, leads to the round window. So we have an oval window first and a round window second. The cochlear duct lies in between those compartments, and it's separated by a vestibular membrane, and then there's also a basilar membrane. So vestibule is on top, tympani is on the bottom. And they are basically just two compartments. So here's the scala vestibuli. Here is the membrane that separates them. Here's my scala tympani. This is going to be the bottom. Both of these contain perilymph. These are the outside part. Here is the actual cochlear duct that contains the endolymph. So V over T, your cochlear duct is in the middle, perilymph is both out here, vestibular membrane on top, basilar membrane on the bottom, And then spiral organ that's found in here is important for picking up actual sound waves. So the organ of Corti, or the spiral organ, has your hair cells which pick up the sound waves. It lies down on that basilar membrane, so a lot of the fluid will be on top of it. The hair cells are little hairs that extend into the endolymph, so into that fluid, and it's going to pick up sound waves through that fluid. So hair cells pick up sound. Above the hair cells is a tectorial membrane, and that basically just is going to touch the tips of the hair cells. So here we're very magnified. Here's that tectorial membrane, and then here are the hair cells with the little pieces of hair up on top of it. These are the neurons that are going to lead to these hair cells. So once these hair cells pick up sound, it's going to go to your nervous system. And here's that basilar membrane that the hair cells sit on top of. So like I said, that's very magnified. Vibrations of the fluid inside your ear cause the hair cells in different parts of the spiral organ to bend. So these little hair cells move with that fluid. And that results in an influx, a large amount of calcium ions. So little did you probably know that calcium is very important for your hearing. And that causes the release of a neurotransmitter from vesicles, and that neurotransmitter is going to stimulate those sensory neurons to pick up sound. Louder sounds cause more neurons to be motivated. So more action potential. If you have soft sound, you don't need a lot of hair cells to work. If you have loud sounds, a lot of those hair cell work. So hearing, like when people damage their hair cells, they have a loss of hearing. It is very good for you with headphones. You know, they say you shouldn't listen to loud music, la-da-da. I'm not saying that it's good to listen to loud music, but it's worse to listen to the same sound over and over. You should actually fluctuate the volume, because when you listen to the same volume all the time, it's the same hair cells that are being used. So it's good to change the volume that you're listening to. So then those nerves are going to pick up the impulses, and they're going to take it to the temporal lobe, so your hearing occurs just a little bit above your ears in your brain. Some of the fibers cross over, and hearing loss can either be conductive, so caused by something close, or sensorineural, and that's what I was talking about. Overuse, sensory overuse can lead to hearing loss. So here's a table. This is in your book. This just gives you step by step. I've broken it down. It puts it all together, starting at the external, ending up way inside. And that's it for hearing. So next time, hearing, cochlea. Next time we'll talk more about the semicircular canals and how that affects equilibrium.